Assalamu alaikum everyone. Today we will discuss on the bar bending schedule of columns. It's a very important thing after footing. We go for a column. Okay, column is the structural member which takes the compression load. So it is a compression member. Okay, all the compression loads are in our structure is taken by our column. Now we should know the basic ideology of column because we use the reinforcement in the column. Minimum, if we have square column, we use 4 number of bars. If we have circular column, we use minimum number of bars is 6. It depends upon the shape and size of column. So today we will know about the bar bending schedule of column. So here we will start. Here is my, you just see here is my diagram, the typical view of column with foundation. You just see here, it's, because it will take more time if I draw this one and one, that's why I make it faster. So here I have the footing, this is my total footing, and then this is my footing jolly, and this is my column starting from here and go up. Okay, now here we will see one thing. First, this is my footing jolly, then here this is the distribution bars in footing, then I have my column starts from here. This is my column. Okay, this is L. This L usually we take 300. Okay, if it is not mentioned on drawing, then we assume it 300. Generally we take it 300. Then I have column, it goes up to the plinth level, so up to the plinth beam. This column we call as pedestal. The thickness, the thickness of pedestal is always more than the thickness of column. Okay, but here I take it in general way, I take the column simply, but you should know that thing. So it goes up. The thickness of my footing is, the total is 1.500 meter, 1500 mm. Then this is my ground floor level, GF level, and this is my plinth level. Okay, this is my plinth level, and the height is 600 mm, and this is my plinth beam, and the height is 200 mm. Now generally we have the floor height 3 meter. So then I have 3 meter height for one. This is the first column. Okay, so ground floor starts from here. This is 3 meter height. Then the slab thickness is 175. The slab here I have the first slab, and then I have second column for second floor. This is 3 meter again, and the slab thickness is 175 mm, and this is my second slab. And then again I have 3 meter, that is typical thing, 3 meter height of column, 175 is the thickness of slab. This is my slab 3. And lastly I have height of fourth column, it's 3 meter again, but then here I have a roof. The roof thickness is 150 mm. Okay, it is a typical view of my column, B column. Okay, here you see the second thing, this is my stirrup. So if I see this drawing, this column from upside, it will look like this. This is the sectional thing. Here I have the one bar, vertical bar, second vertical bar, third vertical bar, fourth, fifth and sixth vertical bar. 1 bar, 2 bar, 3 bar, 4 bar. These bars have the diameter 20 mm. These are 4 types of bars. 1, 2, 3, 4 having diameter 20 mm, and the middle 2 bars having only 2 bars having diameter 16 mm. Okay, 16 mm. So you know the cover is 40 mm on both sides. Cover is that thing, as I told you earlier. If this is my reinforcement, it starts from the end of reinforcement to the column face. This is called a cover, clear cover. Okay, here we take it 40 mm on both sides. This is all about cover. So we will talk about the vertical length. What will be the vertical length of this BBS column? The vertical length will be, if I first talk about these two things, I mean this column and this bar and this bar, these are, we have 4 number of 20 mm bars, 1, 2, 3 and 4. So here I write here, it is, if I will take first 20 dia bar. For 20 dia bar I will calculate all the length. First I will take this length from L length, it is 300. Okay, you got this. Now second I will add this length, the length from this to this, it is 1500 because the total thickness is 1500, minus cover, the cover is, we take the cover 50 mm, minus 25 is the dia of main bar, I mean the dia of footing jali below, this is the 25 dia, minus 25 is the dia of distribution bar. So always minus cover, minus distribution bar, minus steel bar. Okay, the dia is 25, that's why I take here 25 and 25. Now plus 600 is the height from the top of footing to the plinth level. Okay, this is 600. Then I have 200, I will add here 600 plus 200. Then I add 3000, I mean 3 meter into 4, because I have here 4 columns. You just see 3 meter 1, 3 meter 2, 3 meter 3, 3 meter 4. So 3 meter into 4 times. I will calculate the total length. So 3 meter into 4. Plus I will add 175 into 3, because 175 is the thickness of slab. It is 3 times. So you just see here is 175 1, 175 2, 175 3. So I just what I do, I just add 175 into 3 times. Now plus I go for development length, which is a very important thing you should know here. Let me tell you one thing. If this is my bar, this is my lap. Okay, you have any idea about lap length? This is my lap length. This is called lap length. And the second lap length is that length, the main motto on lap length is it transfers the load from one steel to another steel. But what about development length? Here, if we talk about here, this is my top of column. Okay, it is my terrace, I mean the roof. This is called development length. The development length is that length which transfers the load from steel to concrete. Okay, that is the difference, is the main difference. So always what you take, development length is indicated as LD and we take it 50D. Okay, what about lap length? Lap length may vary, it depends upon the grade of concrete. If we use M25 we take it 45D, if we use M20 we take it 50D, but development length is 50D. Okay, so we measure the development length from the top of column to the end of the bar. Never take length, don't take the length from this point to this point. Always take the length from the top of bar. This total length will be the development length and it will be 50D. Okay, that's why I here I add the development length, that's it's 50D. The diameter of bar is 20 minus the bend, the total bend. As I told you earlier, for one band we subtract 2D. Got me? So how much bands I have? I have 2 bands. Okay, so what I do, I just subtract 2 into 2 into diameter of bar is 20. That's 2 into 2 into 20. When I add these all things, I got 15945 mm. That is 15.945 meter, which is greater than 12 meter. Okay, so it is greater than 12 meters. So if the total length is greater than 12 meter, what we do, we just go for lap. Okay, I will tell you here, I will tell you the interesting about lap. Okay, always do the lap in the column in this manner. Suppose this is my column and the height of column is 3 meter. Okay, what you do, you just make a center line as I show here. This is as I show here, this is the center line. This is very important thing. So I have to give the lap. I have a column. Okay, I have a column here. First I will tell you this thing. The column, every column have 3 zones. It's divided into 3 zones: zone A, and the last is zone B. Okay, zone A, and zone B. What happened when the wind load or earthquake load or lateral load comes to the column? This is my column. When the wind load comes to the column, it will deflect. When the wind load comes or earthquake load comes to the column, it will deflect like this, and the maximum moment will develop on the toe of my column. Maximum moment will be developed in this area. When the load is coming, the wind load, earthquake load, the maximum moment develops here. So that's why we call it zone A and zone B. That is the main reason. Whenever you go for lapping, always give the lap in zone B. Never give the lap in zone A. Never give the lap in zone A. Okay, always give the lap in zone B, because zone B is having less load. Less load is coming in zone B. And what about A? There is a maximum load, maximum moment which is coming in zone A. So always give the lap in zone B. So here I have the center line. What I do, if I have to give the lap in staggered manner. Okay, if this is my this is my center line. Okay, usually on the structural drawing, there's mentioned already that the spacing from the end of lap to the end of another lap, in general case we take it to 150 mm. So from center I will go up 75 mm, and from center down I will go down 75 mm. So here 75 mm I will give one lap. And here's one thing, we always give the lap to the upper bar. Never give the lap to the down one bar, because this bar is fixed from below side. So we add the bar, the new bar which we added from upside. So we have to give the lap to that bar. Okay, that is the very important thing. This is my lap. I bend this thing. Okay, so this is my lap. This lap is above the center line. You got me? And here is my second lap. This lap is below the center line, 75 mm. So from the end of this point to the end of this point is 150, and from the center line to this point is 75 mm. You got me? Okay. So whenever you go for a lap, just give the lap in B zone. Always remember this thing. Okay. And this A zone, what about A zone? This A zone is approximately, it's always L by 6. So this is L by 6. And what about this? If total is L minus L by 6 plus L by 6, we got 2 L by 6. 2 3s are, we got L by 3. L by 3. 3L minus L by 3, it is 2L by 3. So this will be 2L by 3. You got me? So L by 6, just leave this thing, just remember this thing. L by 6 will be zone 1, L by 6 will be zone 2. Okay, if the total height of my column is 3 meter, so just to go for 3 meter divided by 6. So 500 mm will be this zone, and 500 will be this zone. So if I go 2 into 3 meter divided by 3, this will be 2 meters. Simple. This will be 2 meters. This portion, leave this thing. You have to remember this thing, L by 6. This should be 500 mm and 500 mm. So whenever you go for lap, give the lap in zone B. Okay, this was all about this lapping, and lapping is very important thing here. So I will give here we come to our topic. We was here. So my total length comes 15.945 meters. It is greater than 12 meter, because the total length of single bar is 12 meter. Okay, so but my total length comes 15.945, so I have to give one lap. I will add one lap, that is 50d. I will add one lap. The lap we take here is 50d. So the total length is 15.945 plus 50d, diameter of bar is 20. It's very simple, and I got 16.945, that is 16.945 meters total I got. So but total length will be 16.945 into how many bars I have, having 20 mm dia. 1 2 3 4. So multiply simple here by 4, I got 67.7 meter. So I need 67.7 meter total length of bar. Total length I need this 67.7 meter. So here we will take the 16 dia bar. Okay, here I have the 16 dia bar. I have two 16 dia bar, 1 and 2. Leave these things, we have find the total length. Now we will find the total length for this. Here you may have some confusion in these two bars. Actually this is like in this manner. Okay, I'll show you here. This is the plan, the section, the vertical section. These are my bars, the 4 bars, the 20 mm 4 bars which we have find earlier, the total length. And this is the bar, the 2 bars, 1 bar and 2 bars. Okay, these two bars, these two bars, just show here. These 2 bars are here, 1 and 2. You got me? Okay, now we will find the total length for these 2 bars. It's very simple. How to find the total length? Guys, now we have the 16 dia bar. For 16 dia bar I will find the total length. I will first take the 300 mm, the L. Here you just see the 300 mm. This is the 300 mm L. Okay, now 300. I will first take the 300 mm L. Then I will take this distance. This is 1.5 meter total distance. So here it's Sam the 1500 1500. One thing you should remember here. This bar is on the main bar. Okay, here is not any distribution bar, so I will subtract only one main bar. I will here because it just lies directly on the main bar. Okay, that's why I subtract here only one main bar. Here you just see here it is my 1.5 meter is the height, total height. Here just see, then I subtract minus 50 is the clear cover. Okay, minus 25 is the dia of main bar, because it's directly lies on the main bar. Here isn't any distribution bar, that's why I only subtract minus 25. Okay, plus 300 plus 200, Sam just see here, plus 300 plus plus 600 plus 200. Okay, here plus 600 plus 200 plus 3 meter into 4, because the 4 columns are coming, that's why I mentioned here 3 meter. You just see 1 2 3 4, 3 meter into 4, 3 meter into 4. Okay, plus 175 into 3, because 175 is the thickness of slab. 3 slabs we have, 1 2 and 3, that's why 175 into 3 plus 50 into 16. 50 into 16 is the developmental length, 16 is the diameter of bar, that's the 50d. Okay, 50d, d is the 16, that's why I mentioned here 15d. Minus, for 1L what we have, for 1 band we have 2d, for 2 bands we have 4d, that's why 2 into 2 into 16. This we subtract this thing in every bar, in every band. Whenever we have band, this is very important thing. Whenever we have band, suppose I have the bar having 1 band here. Okay, so what I do, I just find this length, then I find this length, I just add these lengths, then I subtract this band. This band is always 2d, we take it 2d, then I subtract 2d. That's why I subtract here, because I have two bends, one bend and two bend. 2 into 2 into D is the 16 is the diameter of bar. So I got 15.78, which is greater than 12. So I go for lap. There is one more lap. Okay, so one lap is added here. So when I add lap, it is 15D. Okay, 15D is the lap length. Okay, the total length is 15.786 plus 50D is the dia bar, that is 16. So I got 16.586 meter. I mean 16.58 meter. But the total number of bars is 2. So multiply by 2, I got 33.16 meter is the total length for 16 mm bar. Okay, so guys, here I will tell you one thing, that's important thing. In general case, what we do when we go for lapping is the most important thing. First, whenever you will give the lap in the middle, in zone B. Okay, then the lapping which we are giving, we have usually 12 meter bar. We will give the lapping, in general case we will give the lapping if the height of column, I mean if the height is greater than 4.5 meter. Is the general case 4.5 to 5, they take it 5. If the height lies between 4.5 to 5, we give one lap. You got me? Okay, so if I have a bar having, I mean if I have a bar having dia 12, I mean having dia 12 meter, so I have to give the lap. I will give the lap, I will do 12 divided by 2, that is 6. After 6 meter it will be my lap. So this will be 6 meter, okay, and this will be 6 meter, but there will be the extra length. Extra length is the developed lap length. It depends upon the grade of concrete. We take it 50D. Okay, if the dia is 20, what I do 50 into 20. The simple is 50 into 20. It is 1000. So the total lap length will be 1000. You got me? Okay. Now here we have our plan, this thing. So we find the total length, that is 33.16. Now we'll talk about the most important thing, how to find the stirrups, in this, how to find it. So here I will tell you that thing. If I have column, simple, if I have column here, okay, I divide my column into 3 zones, A, and B. So the maximum moment is coming in zone A, you know this thing. So I will give more stirrups in zone A than zone B. That is, the spacing of zone A, the spacing of stirrups in zone A will be greater than the spacing of, the spacing is less than the B, in spacing B. Okay, if this, I will give the spacing, let's take the example, I will give the spacing 100 mm is the spacing in zone A. So 100 mm is the spacing in zone A, and here I will give the spacing 200 mm spacing, okay, in zone B, and center to center distance. Okay, you got me? That's the main thing. Now here, if I give the spacing, what about the total length? The total length of my bar is, total length of column is 3 meter. 3 meter. Always remember one thing, from the bottom of slab, here will be the bottom of slab, just go down 50 mm, then start the first stirrup. This is very general thing. And here the same thing, from the top of slab to the up, just to go 50 mm up and give the first stirrup. Got me? Now here, if I have 3 meter minus 100, first 50 minus 50, so I have 29 2900 is the total length. Okay, so 2900 is the total length. So I have to give the I will calculate the total how many stirrups I need in this position, from the bottom of slab and from the top of slab, how many stirrups I need if this is my reinforcement. So we know this is L by 6, so this also L by 6. So I have 29000 divided by 6, simple. So I need 4.833. I mean 483. 483.3 is the height of zone A, and here is also the 483.3 is the height of zone B. One thing you should remember, the other thing which I should mention here, if this is my column, this is zone B, what we do whenever we go for stirrups, when we have to find the number of stirrups, we add extra one stirrup in zone A, and same we add one stirrup in zone A. What about B? We always subtract one stirrup in zone B. Okay, this is the thing you should remember. Now I will tell you here one thing. So it is 483 by 3. So what about this length? This length will be 2L by 3. I mean this will be 2L by 3. 2 into 2900 divided by 3, this will be 1933.3. so now we'll find the total number of steps, how much we need. So we'll find it 480. we'll find first this. I have 483.33 divided by the total spacing is 100 divided by 100. So I got 4.83 number of stirrups. I add just here, I got 483.3. I add 1, so I got 5.83, which is approximately 6 stirrups I need. 6 stirrups I need in this zone and 6 stirrups I need in this zone. What about the middle zone? Middle zone I need, the length is 1933.3. okay, 1933.3 divided by spacing is 200. I got 9.66. I subtract 1, that is 8.66, which we take approximately 9 bars. I mean 9 stirrups. So I need 9 stirrups in this zone, and I need 6 stirrups in this zone and 6 stirrups in this zone. So the total number of stirrups is 6 plus 9 plus 6, that is 6 plus 9 plus 6, that's 21. The total number of stirrups here we need 21. Okay guys, I forget one thing here. This is my lap length. Okay, lap length, always remember this thing. If this is my column, the lapping never comes in the same phase. Okay, it never comes in the same phase. It always comes, if this is my column, the one lap will come above the center line and the other lap will come below the center line. And the lapping, if the one lap is LD, the other lap will be 2LD. Okay, this will be twice the LD. Okay, if one lap is LD and the other lap is 2LD, that gives us the staggered thing, that gives us the unequal thing, which is very important for load distribution. Okay, now we will talk about the how to find the total length for stirrups. Okay, this is very important thing, how to find the total length for stirrups. If this is my stirrup here, this is my stirrup, the thickness of the total thickness of stirrup is, I mean the total length of stirrup is 600 mm, and the height of stirrup is, I mean width of stirrup is 300 mm. Okay, remember this thing, 600 and 300. Remember one thing, if I am using the rectangular stirrup, what we do to find the total length, what we do, I have the formula, that is the parameter of rectangular. Parameter of rectangular is twice into length plus breadth. If I am using the square stirrup, for that I have the formula 4a. 4 into a is the number of sides. That's a simple thing, parameter and the for square. Here we have the rectangular thing, 600 into 300. Okay, I want stirrup here. The stirrup is like this. This is my stirrup. Okay, so if this is 600, we just first subtract the cover from both the sides. The cover from this side is 40 and the cover from this side is 40. So the total cover will be 80. So I got 520. And from the center of my ring, from this side the ring is 8 mm. From this side I have 4 mm and from this side I have 4 mm. So I got 528 for this. If I go for breadth wise, I have 300 minus cover from both sides, that is 80. So 300 minus 80 is 220. Am I right? 220 plus 8, 4 mm from this side, 4 mm from this side, from the center. That's 8. That is 228 is the total length. 228 mm is the total length. So how to find the total length of stirrups? Total length of stirrup. We know the parameter of rectangular is twice into length plus breadth. I just see here parameter of rectangular is twice into length plus breadth. So twice into what is the length? 528. What is the what is the breadth? It is 228. And plus we have here this, we have one band and this we have second band. Okay, for that we take 16D. Okay, 16D, we add the 16D because we have two major bands here. Okay, actually we have if we go deeply, we have it looks like this. So it looks like this for one band, and for second band we have this for 4D, and this if we go deeply 4D. If we add 4 plus 4 plus 4 plus 4, we got 16D. So that's why we add 16D. Simply just remember this thing, we add 16D minus the number of bands. How many bands we have here? I just show you here how many bands I have. Just see here, 1 band, 2 band, 3 band, 4 band and 5 band. So I have 5 bands. So I will subtract if I have 16D, I'll subtract 5D, twice length, 528 plus 228 plus this thing. So I got this thing to find I have rectangular, twice length plus breadth plus 16D minus 5D is the total bands. So I got 2 into 528 plus 228, 528 plus 228, 528 plus 228. So I got 756 plus 16, why D is the diameter of stirrup, that is the 8, minus 5. I can simply go like this, 16D minus 5D is simply the 11D. Okay, so I got 2 into 756 plus 11D, 11 into 8, that's 88. So when I 2 into 756 into 80 plus 88, I got 1600 mm will be the total length of stirrup. Okay, you got me? So it's simple thing. So what you do, we should know the parameter, that is twice into length plus breadth, twice into length plus breadth plus 16D. Always go for 16D, then subtract to 5 bands, 5D. You can write it as 11D, simple. 11D, simple. So when we add all these things, you will get the result. I have this here, I have 1600 mm. So guys, it was the introduction about column, how to find the total length of bar, and how to find the number of stirrups, and how to give the lap in the column, and how to find the total length of stirrup. Thank you for watching.